Okay, so we've done some examples where we had maybe what were more easily identifiable inverse Laplace transforms. So in this video, we want to calculate the inverse Laplace transform for this function f of s, which is s plus 2 over s squared plus 4s plus 11. And if you look at the table really closely, you really won't find anything that matches up too perfectly. But let me just kind of focus in on the Laplace transform. So in the column over here, we have our exponential times sine or exponential times cosine, and these are the corresponding Laplace transforms of those functions. And so looking at these two, it seems like maybe this matches up with the cosine a little bit, but it's hard to say exactly because these Laplace transforms are written so that the denominator is already organized in such a way so that we have some square plus some constant squared. And over here, maybe we have the result of after if you were to distribute this in group terms. So we want to take our function and try and rewrite it in a way that it's more clearly identified with one of these more common looking forms over here. So the suggestion here might be, let's see if we can complete the square for the denominator. And so to complete the square, because I have a 4 over here, this means I'm going to choose a quadratic term, right, that's going to give me the 4s. And then I just need to figure out how much additional stuff I need to add or maybe subtract in order to balance the equation. So if you were to multiply this out, you would get s squared plus the 4s that we want plus 4, but we want 11 over here, so that means we would need to add another 7 onto the right side. So basically all we're doing is completing the square of the denominator. And so that means I can take our function f of s, and we have an s plus 2 up top, and then down here we have an s plus 2 squared plus 7. And now that I've completed the square, I can see that this looks much more like this example over here. In fact, it looks exactly like that example. We have an a value which is equal to minus 2 in this case, and we have a b value which is equal to the square root of 7. So therefore, the inverse Laplace transform of f of s is going to wind up being e to the at, where our value for a was minus 2, and then we're going to multiply by the cosine of b, which was square root of 7 times t. So here would be our inverse Laplace transform for the given function. So mostly finding these inverse Laplace transforms involves doing some algebra, such as completing the square, and we'll see some other examples, such as doing partial fraction decomposition.